Class 11th Chemistry Bridge Course Lecture 3 YouTube channel Lingareddy Chemistry JNEET Chemistry for IIT JNEET.blogspot.com for material by Lingareddy Pisati. Like, share, comment and subscribe the channel. Today we are going to discuss these all 6 topics: isotopes, isobars, isotones, isodiaphers, isostars, isoelectronic species. What is the difference between all these 6? How to remember? Easy trick. I will teach you just a few minutes video. Listen carefully and you can comment after the video. The first one, isotopes. Isotope. Here P word is there, just you remember P. P for protons. Protons. P for protons. Isobar. Bar means mass. Isobar means mass. Isobar. Isotone. Isotone. N. N for neutrons. Neutrons. Okay, now 3 definitions. Easy trick I am telling you how to remember. Isotopes. What is iso? Iso means same. Iso, same. Isotopes, same number of protons. Same number of protons. Isobars, same atomic mass. Same atomic mass. Isotones, same number of neutrons. Same number of neutrons. Okay, the first point is clear. How to remember? Isotope, P for protons, isobar, mass, isotone, neutrons. Right. Now definition. Number of protons and electrons are same. Neutrons are different in case of isotopes. Okay, so isotope, protons same. When we are talking about proton means obviously next thing is neutrons are different. Neutrons are different. Okay, in these 3 things we don't discuss about electron. Okay, but we know that in the neutral atom proton equal to electron. That's why number of protons, number of electrons are same in isotopes. Right. The main thing is here neutrons are different. Next, isobar, mass is same. Mass means you know that A equal to P plus N. P plus N. Right. Isobar, this P plus N total is same. What is the different? Obviously the proton is different. Protons are different. So in the definition, what we will write whenever we are telling about mass, then in the definition we will mention atomic number. Atomic number. When we are talking about protons, we will talk about neutrons. When we are talking about mass, we will talk about atomic number. So mass is same, atomic number is different. Atomic number is different. Okay, here protons same, neutrons different. Here mass is same, atomic number is different. Next, similar to isotope, here isotones. N for neutrons are same. When neutrons are same, what are the different here? What are the different here? Obviously number of protons different. Number of neutrons are same, number of electrons and protons are different. Okay, protons different. Protons different. See here, first definition and third definition is quite opposite. Okay, first and third quite opposite. P is same, N is different. Here N is same, P is different. Isotope, isotone. और बीच में आ गया isobar. Bar means mass. Same mass, different atomic number. Understood these three? It's clear. Now I will give you few examples. Isotope, protons same, right? So I am giving 1H1, 1H2, 1H3. These are number of protons. These are number of protons. How many protons are there? This is equal to atomic number. This is equal to Z, that equal to atomic number. Atomic number equaled number of protons as well as number of electrons. Number of electron also, right? Same atom means number of protons will be same. What about neutrons? Neutrons will be different. Neutrons will be different. Here how many neutrons here? Neutrons is 0. Here neutron 1. Here neutron 2. How I got it? The formula is A equal to P plus N. P plus N. See here the total mass is 3 already given. So number of protons 1 means obviously neutrons will be 2. Neutrons will be 2. 2 plus 1, 3. 1 plus 1, 2. 0 plus 1, 1. Got it? Some more examples. 6C12, 6C14. These two are also isotopes. Why? Number of protons. See, I will write here number of protons in this both cases. Number of protons 6, 6. Number of electrons also will be 6 and 6. Number of neutrons here 6, here 8. Number of the total mass is 12 and 14. The mass is equal to N plus P, number of neutrons plus number of protons. Electrons we don't add in the mass. Okay, so 6 plus 8 14, 6 plus 6 12. You can see here 12 and 14. So I can define this again. Isotope means same atomic number and different atomic mass. Different atomic mass containing species are known as isotopes. This is one definition. The second definition is same number of protons, but having different number of neutrons. Those are known as isotopes. I hope now everyone you understood this isotope. Is it clear? We can write two definitions. Next, isobars. Isobar, same atomic mass. See here, argon is there 40, calcium 40. Atomic number 18 and 20. Atomic number is different. Atomic number is different, but atomic mass is same. Those are known as isobar. In the bar meaning mass, you have to remember, bar equal to mass. Iso means same atomic mass but different atomic number, right? Suppose 7N14, 6C14. These two are also isobars. Got it? Next, isotones. In the isotones, n neutrons are same. Neutrons are same. I will take one example here. Sodium 1123. In this sodium, how many protons are there? 11 protons. How many neutrons? 12 neutrons. Next, 12 magnesium 24. How many protons are there in a magnesium? 12 protons. How many neutrons? 12 neutrons. Now you can see here same number of neutrons, but atomic number is different. Yeah, number of protons are different. So n neutrons are same, protons are different. Okay, we can say instead of protons, we can say here atomic number is different. Number of neutrons are same. Okay, got it? One more example. See, one more example here. Sulfur 1632. How many protons? 16 protons, 16 neutrons. Now I am taking 15 phosphorus 31. In this case 15 protons, atomic number is 15, so 15 protons will be there. Okay, then what about neutrons? Neutrons will be 16. If you have any confusion, you can add these two. This total equal to atomic mass. 15 plus 16 equal 31, so 31 is atomic mass. Okay, number of neutrons are same. Number of protons are different. Okay, now three definitions I explained you, so I hope everyone you understood. Yes, next three definitions we are going to discuss here. Isodiaphers, Isoelectronic, Isostars. The species with same isotopic number are called Isodiaphers. What is that isotopic number? You can see here isotopic number formula is mass number minus 2 into atomic number. Example given here, mass number, what is the potassium? 19K39. Mass number 39 minus 2 into atomic number. That means 39 minus 38, that equal 1. In case of 9-fluorine 19, mass number 19 minus 2 into atomic number, that equal 19 minus 18, that equal to 1. Here also 1, here also 1. So this difference, mass minus 2 into atomic number, as well I can write here n minus p value. If it is same, n minus p value is same, that is also known as isodiaphers. Okay, you can see the definition again. Isodiaphers are a set of nuclides that have a different number of protons and neutrons, but there is the same difference between the proton and neutrons. Okay, so the example is given you 9F19 19 potassium 39. Number of protons. What about protons here? 9 protons, here 19 protons. What about neutrons? Here neutrons, 10 neutrons, here 20 neutrons. What about n minus p value here? Here also 1, here also 1. Okay, where the n minus p value is same, those are isodiaphers. Those are isodiaphers. Are you getting? Is it clear? Shall I give one more example? See, sodium 1123 and aluminum 1327. I am writing here number of protons. Number of protons equal 11 and here 13. Number of neutrons. See here 12 neutrons, here 14 neutrons. The n minus p value is here 1, here also 1. So sodium and aluminum, these two are isodiaphers. Right? Isodaphers. Next, isoelectronic. What is that? Same number of electrons. The ions with the same electronic configuration as noble gas atoms are said to be isoelectronic with the noble gas. The size of the ions depends on the relative number of protons and electrons. Here one more point we are learning. The size, how the size will be there. First of all, we will discuss isoelectronic means. See here, neon. How many? What is the atomic number? 10. Fluorine, atomic number 9. Sodium, atomic number 11. Magnesium, atomic number 12. What about electrons? Obviously equal to their atomic number. This is the atomic number. But now I am taking their ions. I am taking here F minus 1, Na plus magnesium plus 2. So number of electrons equal to 9 plus 1, that equal 10 electrons. Here 0 charge, that means 10 electrons. Here 11 minus 1. Why I am writing minus 1? Because plus 1 is the charge. Plus 1 means, it mean 1 electron loss. That means 11 electrons it should be in the sodium, but 1 electron loss. So right now 10 electrons are present. From magnesium 2 electrons left. So 10 electrons remain. So in all these 4 atom and ions, the number of electrons are having 10, 10, 10. All 10 electrons. So these are isoelectronic species. Okay. Next, not only this, I can write some other examples here. Isoelectronic, suppose carbon monoxide and nitrogen N2. These both are isoelectronic. How? Carbon 6 electrons, oxygen 8 electron, total 14 electrons. N2, nitrogen 7, one more nitrogen 7, total 14 electrons. These both are isoelectronic species, isoelectronic compounds, isoelectronic molecules. Okay, isoelectronic matlab understood? Here one more point I will teach you. Always in case of in case of isoelectronic, negative charge size is bigger than neutral than positive. Okay, see here, O minus. If two negative charges are there, more negative charge is bigger one, then less negative, then neutral, then positive. When more positive one is smaller in size. Okay, size also we discussed here. Next, isosters and isosisters also it is called. So isosters are atoms, molecules or ions of similar size containing the same number of atoms and valence electrons. In the last definition we discussed only electrons. Here number of atoms and valence electron both should be matched, then only these are isosters. Example, N2CO. Atoms, how many atoms? Here 2 atoms. Number of electrons, so 14 electrons. Okay, you can say nitrogen and carbon monoxide isoelectronic also. Yes, it is possible. Isoelectronic as well it is isosters. Isoelectronic as well as isosters. See here, 18 electrons. So isoelectronic, number of atoms only 1, so isosters. Okay, isosters. So note point here, for isosters it would be follow isoelectronic. Okay, isoelectronic compulsory. If see one example here, isoelectronic but not isosters. I will give an example here, then it will be clear what are isosters and isoelectronic. Right here N2 is there, N2 and silicon. These both are, how many electrons here? 14 electrons. Here also 14 electrons. So these are isoelectronic. But number of atoms here 2, here 1. Therefore not isosters. Okay, for isosters what should be? See here, 14 electrons. Atoms should be same. Atoms here also 2, here also 2. Therefore these both are isosters. So I can give one statement here. All isosters are isoelectronic. But not all isoelectronic are isosters. The reverse is not possible. Okay, the reverse is may or may not be. Okay, here one example is there. Match the following. We can see all atomic number is same. Means protons are same. Mass is different. So these are isotopes. So this one is, first one answer is A. Next, See here top, mass is same. Mass is same. Of course, here it should be E, helium. Mass is same. So isobar. Isobar. So D is the option. Isobar. Bar means mass, right? See, atomic number is different. Atomic mass also different. So here we have to see N minus P value. N minus P. What about number of neutrons here? This is the atomic mass. This is the atomic number of protons. Number of neutrons N equal to A minus P. A minus P. That is 76 minus 32. 44. In the second case, arsenic, N equal to A minus P. Atomic mass 77 minus number of protons 33, total 44. So N minus P is same. N minus P same means isodiaphers. Isotones, right? So it is C option. C option. Already this is the A option. It is a D. C. Next. 92 uranium 235, 90 thorium 231. See, atomic number of protons not same, so A option wrong. Isotones, so calculate number of neutrons. Isotones, N equal 235 minus 92, that equals 5 minus 2, 3, 23 minus 9, 143 here. Here 231 minus 90, 123 minus 9, 14, 141. So isotones, B also wrong. Then isodaphers is N minus P value. N minus P, 143 minus P, 92, that equals 1, that means 51. Here N minus P, 141 minus 90, that equals 51. Yes, 51. N minus P value is correct. So C option is correct. Fourth one is C. Then fifth one, this is a hydrogen, deuterium, tritium. Number of protons are same, so A option. Okay, like this you can solve the